Assalamualaikum and hi everyone. We will continue chapter 9, differentiation, lecture 4 of 5, part 1. 9.4, implicit differentiation. At the end of the lesson, students should be able to find the first derivative implicitly. 9.4, implicit differentiation. An equation that can be written in the form of y equals to fx is said to define y explicitly as a function of x. Examples are y equals to 3x squared plus 7x minus 3, y equals to cos 3x minus 7ax are explicit function. If y are not alone on one side of the equation, we say that the equation defines y implicitly as a function of x. Examples are x squared plus y squared equals to 3 and cos xy plus 7y equals to 8x are implicit function. Number 3, the process of finding the derivative of an implicit function is called implicit differentiation. Number 4, to differentiate an implicit function, it is not necessary to change the implicit function to an explicit function. It's not necessary. To differentiate y with respect to x is d dxy, that is dy dx. To differentiate y to the power of n with respect to x is d dxy to the power of n is equals to, we have to bring n in front, multiply with y to the power of n, you have to minus 1 here. Then you haven't finished yet, you have to differentiate y. Differentiate y is dy dx. So you have to end up with dy dx. Okay, so you have to memorize this formula. Okay, if given y equals to fx, yn is equals to fx to the power of n. So differentiate on your left side, y to the power of n is equals to differentiate fx to the power of n. Okay, so now differentiate fx to the power of n by using power rule. You will get n multiply with fx to the power of n minus 1. Then you have to differentiate fx. So the answer is n y is equals to fx, so replace fx is with y and minus 1, dy dx. So this is the answer for differentiate y to the power of n. Okay, got it? Okay, now we move to first order derivative. Example 1. Find dy dx in terms of xy if given the function as y cubed plus 6x equals to x squared. Okay, now we move to first order derivative. Example 1. Find dy dx in terms of xy if given the function as y cubed plus 6x equals to x squared. Now we differentiate each term with respect to x. With respect to x. So you will get differentiate y cubed, differentiate 6x, differentiate x squared. Each term you have to differentiate with respect to x. So you will get 3y squared, then you have to differentiate y, dy dx. Plus differentiate 6 with respect to x, 6. Differentiate x squared with respect to x, 2x. Then you have to bring 6 to the right side. Okay, then what is dy dx? Dy dx is equals to 2x minus 6. You have to divide by 3y squared. Okay, this is the final answer. Okay, now we continue example B. Differentiate 3y squared plus 2y plus xy equals to x cubed. Now we will differentiate each term with respect to x. Differentiate 3y squared plus 2y plus xy and differentiate x cubed. Please take note that on your right side, this is the explicit differentiation. Okay, but on your left side here, this is an implicit differentiation. So you need to differentiate each term. Now I will differentiate 3y squared first. Differentiate 3y squared with respect to x. The answer is 3 times 2. The answer is 6y. Then you have to differentiate y followed by dy dx plus differentiate 2y. The answer is 2. Differentiate y dy dx plus differentiate ddx first. Differentiate xy. Okay, we will do later this one. Then differentiate x cubed. The answer is 3x squared. Okay, so now we will copy the answer to dy dx. For this one, we will use product rule here, where u is x and v is equals to y. U prime equals to differentiate x 1, differentiate y. The answer is dy dx. Every time you differentiate y with respect to x, please take note that the answer is dy dx. Okay, so now we will cross here. X, you have to multiply with dy dx. Copy paste x, differentiate y is dy dx plus copy paste x, y, differentiate x. The answer is 1, 3x squared. So we have differentiate on our left and right side already. Now you need to combine the term that has dy dx. So you have to combine the term that has dy dx. So now 6y dy dx, and we have plus 2 dy dx plus x dy dx. You have to bring to the right side here negative y. Okay, then you have to factorize dy dx. Factorize dy dx. So the answer is dy dx 6y plus 2 plus x is equals to 3x squared minus y. And lastly, dy dx is equals to 3x squared minus y over 6y plus 2 plus x plus 2 here plus x. Okay, so this is our final answer. Okay, now we continue our last example, C. Differentiate x ln y equals to e to the power of 2x. Means you have to differentiate left and right side with respect to x. Differentiate x ln y with respect to x, and differentiate e to the power of 2x with respect to x also. So on your right side here, this one, this is an explicit differentiation, where you want to differentiate a function the function in terms of x with respect to x. This is explicit differentiation that you have learned before. So this is easier. The answer is 2e 2x. Okay. Whereas on your left side, you have to use product rule here, where u is x, u is equals to x, v is equals to ln y. U prime is equals to differentiate x, x. Differentiate v prime. Differentiate ln y, the answer is differentiate ln y, but with respect to x. So the answer is 1 over y. We haven't finished yet. You have to differentiate y. Differentiate y is dy dx. Okay. So please memorize that every time you differentiate y with respect to x, the answer is dy dx. Okay. So we will cross the answer here. X multiplied with v prime plus v multiplied with u prime. So the answer is x multiplied with v prime 1 over y dy dx plus ln y, you have to multiply with 1. Okay, then you close the bracket. Okay, we use product rule here. Product rule on our left side. So now what you need to do is you have to bring dy dx on your left side, and the other term you have to bring to your right side. So x dy dx, x over y dy dx, I will remain on our left side, whereas ln y I will bring to the right side, and we have to minus ln y. Okay, therefore our final answer is 2e 2x minus ln y. You have to divide by x, and you have to multiply with y. Okay, so this is our final answer. Got it? Okay, thank you. Okay, so now before we end our lecture, I have a few formula to share with you about implicit differentiation. So you have to differentiate between implicit and explicit differentiation. Okay, this is implicit, this one is explicit. Okay, so for explicit, y is written in the form of fx. Y equals to fx. For explicit, y does not written as a subject in terms of x. So now we want to differentiate any term. For example, differentiate y. The answer is dy dx. Differentiate y with respect to x, dy dx. Differentiate x with respect to x. The answer is 1. Differentiate y to the power of n with respect to x. The answer is, you have to bring n in front, then copy paste y, power for n, you have to minus 1, then you have to follow by dy dx. But if you differentiate x to the power of n, the answer is nx to the power of n minus 1. Differentiate 1, the answer, differentiate x, the answer is 1. You don't have to write actually. So last one, if you want to differentiate ln y, the function is in terms of y. What you want to differentiate with respect to x, the answer is 1 over y. Then differentiate y followed by dy dx. So you need to memorize every time you differentiate y, the answer is dy dx. Okay, and differentiate ln y as usual, the answer differentiate ln x as usual, the answer is 1 over